Hey, Tori, have you ever heard of the golden ratio?
Oh, is that the proportion between those who do have gold and those who don't?
No. The golden ratio is one of the most famous numbers in history.
Famous, huh?
Yeah, there are a few numbers that mathematicians find very interesting that crop up over and over again in interesting formulas. The golden ratio is one of those numbers.
So why is it so famous?
Well, to understand that, we have to understand what the ratio describes.
Go on.
It's the number you get when the ratio between two line segments is equal to the ratio of the sum of those two line segments and the larger segment. So, take a line segment and divide it into a large part and a small part. If the ratio between the larger segment and the smaller segment is equal to the ratio of the whole line segment to the larger segment, that's the golden ratio. Actually, it is easier just to draw it. So, we'll do this. So we have a line segment here, and we divide it like so. So what it's saying is that the ratio between the big part and the small part is equal to the ratio of the whole line segment to the big part.
Okay, that's a little bit better, but what makes it so special?
Well, that's where it starts to get kind of cool. If you draw a rectangle with sides the lengths of both of those parts, you get a golden rectangle.
Oh, is that what they make golden bars out of?
The name golden is actually a pretty new name. The Greek mathematician Euclid called it the extreme and mean ratio.
Right, let's keep calling it golden.
Yeah. The golden rectangle has a property that if you divide it into a square and a rectangular section, the new rectangle is also a golden rectangle.
Oh, that is interesting, but is it useful?
Well, that's what makes the number so famous.
Why would that be?
Well, it probably has to do with recursion. Because of its unique properties, the golden rectangle is self-replicating.
Okay, I remember recursion. It can be used to model lots of things in nature.
Yes. Also, the ratio is useful in constructing lots of geometric shapes. For example, if we continue to divide the smaller rectangles, we get a sequence of nested golden rectangles. And within that nest, we can draw a spiral called...
The golden spiral.
Exactly.
Looks like a seashell.
And that's the point. Lots of things in nature grow according to recursive rules. So shapes similar to the golden spiral appear all the time.
Similar or exact?
Well, very few things in nature follow their models exactly. But the idea that complex patterns can arise from simple rules is what makes models like this so interesting.
So, if the ancient Greeks knew the ratio, what did they use it for?
Well, again, the ratio is useful in constructing geometric shapes like pentagons and decagons. Also, lots of people see the golden ratio in Greek architecture.
So that's the Parthenon in Athens?
Yes, but it's unknown whether the Greeks consciously used the golden ratio or if its relationship to nature and growth influenced them unconsciously. Either way, people have seen the shape there for hundreds of years.
So what is the number?
Well, it works out to 1/2 of the sum of 1 and the square root of 5.
That's an irrational number. That's going to be difficult to draw.
You would think so, but remember, the circumference of a circle is related to the irrational number pi, and it's simple to draw a circle using just a compass.
It's true.
Well, it turns out all you need to draw a golden rectangle is a compass and a straight edge. I'll show you.
Okay.
So, we draw our circle, like so, and then we draw our vertices for a hexagon, but we only need every other point.
Oh, wait, so you're making an equilateral triangle?
Yeah.
Okay.
And then we draw from 2 of the unconnected points to the center of the circle.
So you're bisecting the equilateral triangle on 2 sides.
Exactly. Finally, we draw a line segment from one midpoint through the other midpoint to the circle. The ratio between those 2 line segments is the golden ratio.
You didn't even use a calculator.
Surprising, isn't it?
I have an idea. I think I'm gonna make a pendant in that shape.
Oh, that's cool. What are you gonna make it out of?
Gold, of course.
It's
Golden
not the
ratio.
silver rule.